All right, so we're going to pick up example 4 from what we were doing in class on Tuesday. And we had gotten to the point where we found C2 in terms of C naught. We found that C3 was 0, and then C sub k plus 2 equals 1 minus k times C sub k over k plus 2. And we know this was true for k greater than or equal to 2. Now, you see I've marked this off in a pink box. That is what we need to know for the final exam. I might ask something like that. And this part right here that I'm circling, this is the recursion or recursive formula. All right. So you definitely want to be able to write out a recursive formula for a particular problem. Now, I've gone ahead and I've evaluated this function, or this recursive formula, when k equals 2, 3, and 4. All right, so I'm just replacing the k's with those numbers. And notice that C4 is in terms of C2, and C5 is in terms of C3, C6 is in terms of C4, etc. And this problem is actually in the book, and they go through and write C2 in terms of C naught, and then C3 we know is 0. C4, they write that in terms of C naught or C1. And instead of doing that, we're going to try a really nice trick. And what we're going to do is this. We want to find the first 3 non-zero terms of 2 linearly independent power series solutions. And those 2 are going to be y1 and y2. And the nice trick for this is this. To find y1, we're going to let C naught be 1 and C1 equals 0. And then we're going to find each of C2, C3, C4, C5, C6, and so on. See how this works, okay? And we're going to use C2, there's C3, there's C4, there's C5, there's C6. We can find each one of those, C6. All right, so let's try this. C2 is half a C naught. C naught is 1, so that would be a half. C3 is our formula up here. We know C3 is 0 from the top. C4 is negative 1/4 from here of C2, and C2 is 1/2. So that means C4 is negative 1/8. C5 is negative 2/5 times C3, and we know that C3 is 0, so that's 0. C6 is negative 1/2 times C4, and C4 we just said was negative 1/8, so that's 1/16. And so now y1 would be C naught, which is 1, plus C1, which is 0x, plus C2, which is a half x squared, plus C3, which is 0x cubed, plus C4, which is negative 1/8 x to the 4th, plus C5, which is 0x to the 5th, plus C6, which is 1/16 x to the 6th, and so on. And so let's just clean that up. Y1 is 1 plus a half x squared minus an 1/8 x to the 4th plus 1/16 x to the 6th, and so on. So we've found actually the first 4 non-zero terms, and that's certainly plenty because it said find the first 3 non-zero terms. So we're good to go on that. So I'm going to draw a line. Now that's one of the 2 linearly independent solutions. Let's find y2 now, and we're going to let C naught be 0 and C1 be 1, and generate our list just like we did before. So C2, again, was half of C0, and C0 was 0, so that's 0. C3 is always 0. We've got that from the top. C4 was negative 1/4 C2, and C2 is 0, so it's 0. C5, the formula was negative 2/5 C3, so it's 0. C6 is negative 1/2 C4, and it's 0. I think I'm noticing that once we've got 2 in a row that are 0, right, each one of these is dependent upon the one that's 2 in front of it, so all the rest are 0 here. So this only has one non-zero term. The C1 equals 1. So Y2 would just be 0x, or excuse me, sorry, let's erase that. Try that again. The constant term is 0 plus 1x plus 0x squared plus 0x cubed, and so on. So Y2 is just x. So there's our Y2, and here's our Y1. We've got our 2 linearly independent solutions of this differential equation right up here. And it's nonlinear. It's something, it's not Cauchy-Euler either. It's not something that we can solve any other way so far. And so we've got our 2 solutions. One is a polynomial, and one of them is an infinite power series, so far as we can tell right now. All right, so those are our 2 linearly independent solutions. And we put those together to make a general solution, just like we did before. If you remember, we said C1 Y1 plus C2 Y2. Well, in this case, we're going to change the C1 and the C2. We're going to say C0 Y1 plus C1 Y2. And you'll have to be careful with WebAssign and see what it's asking you to do. And we'll write C0, and we'll put the Y1 in. 1 plus a half x squared minus an eighth x to the fourth, and so on, write down the first 3. And then C1 times the Y2, which was just x. This is our general solution. And we've got it. And that's very, very similar to a WebAssign problem. I hope this helps.